Okay, so last week when we were talking about this, we said the first step to solving any of these to draw that shape, okay, the heating curve of water, right? We're starting here at 3 degrees Celsius. Whoa, that's not where I drew that. 3 degrees, we'll say that's around 3. And we're trying to go to steam at 115 degrees Celsius. So we've got how many steps here? 3. We got to heat the water to boiling, but boil the water off and then heat the steam that's left. Okay, so in step 1, okay, we'll have E equals mc delta T. Oh, that's weird. My screen is all off. That's why it's writing in the wrong spot. Okay, E equals mc delta T. Okay, and so that's going to mean our 400 grams, okay, times, geez, that's weird, 4.2 because it's water, and we're going to multiply that by, we're starting at 3, so 97 degrees. Okay, and then our second step, okay, will be E equals MLV, okay, which would be 400 grams times 2,260. And then we'll have step 3, which will just involve heating up the water, or heating up the steam, sorry, by another 15 degrees Celsius. So E equals mc delta T, because we're changing the temperature, 400 times 2.02 times 15 degrees. Okay, everybody with me there? And then, plug in the numbers and get what we need there. Except my calculator's not going to work because it doesn't know that I'm pressing there right now until I fix it. Is that what you did? Okay, give me a second. I'll recalibrate this and then we'll go. Okay, so when we punch all this stuff in, okay, what we'll have here is, for the first one, 400 times 4.2 times 97 degrees. Okay, and that's going to give us that much. I'm going to add that to the changing of state, so the 400 times 2,260. Okay, and then I got to add that to the temperature changing of the steam, so 400 times 2.02 times 15 degrees. All right, so 107,000. Yeah, so 1,079,080, which is what I've got there. Oh, okay. See, there you go. It's always something simple. Okay, any other ones giving us trouble? On the original? Okay. This one here? Okay, so gardeners often spray their crops before a frost. This prevents the crops from freezing. Explain. Okay, we watched that video there that had the water bottles that were freezing as he was pouring them out. Okay, and what did we say that you might feel if you were holding onto the bottle when that happened? A little bit, not a lot, but a little bit. And what usually happens with a frost is, if it's going to be a light frost anyway, they'll spray their crops, and then as the water that's sitting on them freezes, it releases a little bit of energy into the plant itself and prevents the plant from actually freezing. Okay, so some of that latent heat that is given off when the water freezes, okay, into ice actually prevents the plant itself from freezing. Now, it can't be a hard frost. If it's going to be lower than about like -4 or 5, it's not going to work. They're all just going to freeze then. Okay, they'll be dead and covered in ice. So it only works for a mild frost. Okay, what do we do here when we're going to get a frost? Like with your garden, or especially your tomatoes. You either pick them and take them inside, or you cover them up. Okay, a lot of people will just like throw a sheet over them or something like that, so that the heat kind of gets trapped inside, and the water vapor doesn't freeze onto the plants. Okay, other ones? All right, so the big thing there is just remembering that when we're moving down the curve, energy gets given off. Okay, so when steam condenses into water, energy is given off. When water freezes into ice, energy is given off. Okay, give you a few more minutes here and we'll start biomes. All right, so with biomes, what a biome is a biome is an ecological region on Earth that has certain characteristics. Okay, the things that determine where a biome is located are basically the same things that affect climate. Okay, latitude, altitudes, nature of ocean currents, proximity to mountains, all that kind of stuff basically determines a biome because biomes are a product of climate. Okay, that's why you generally don't find a tropical rainforest up here. Okay, it's not wet enough, it's not hot enough. Okay, all those kinds of things. So what we'll be looking at here is basically the most common biomes, where they can be found, what their characteristics are, and then a few other little things about them. What you'll be expected to do on a test from this stuff is, if I give you a multiple choice question that would have a description of a biome and then also a picture, that you would be able to identify it. Okay, that would be the one of the things that you'd be asked to do. The other thing you'd be asked to do is, if I give you a climatogram, that you could tell me what biome it came from. All right, rather than what city in Canada it came from, because actually that would be quite a bit harder. But what biome on Earth? So, did it come from a tropical rainforest, or did it come from, an Arctic region, or did it come from, a prairie, or something like that? Okay, so being able to look at that climatogram and go, this climatogram is showing a really hot, really wet area that gets rain constantly all year long. Okay, that's probably not the tundra. Okay, so things like that. Everyone follow? That's what you'd be expected to do. All right, so yeah, instead of what I have here, I was sure I changed that, but I guess I didn't. We would say use a climatogram to identify a biome. Okay, so if we're looking at the Earth in terms of where these biomes are, this is kind of what it looks like. All right, and you can see that a lot of the location of the biomes has to do with latitude. Okay, I mean, the green here represents tropical rainforest, and you don't see any tropical rainforest outside of 30 degrees north or south of the equator. Right, which means it is very much an equatorial climate. Right, it isn't gonna be in any places that have distinct seasonality. And basically, the Tropic of Cancer and the Tropic of Capricorn, 23.5 degrees north or south of the equator, kind of mark that dividing line, okay, where there's no seasons and now there are seasons. They're basically the dividing line. Okay, everyone follow me there? Okay, so you can see that there are definitely equatorial climates, okay, and then there are climates that are much more polar. Okay, part of that also has to do with the way land is distributed on Earth. More of our continents and land mass are north of the equator than they are south of the equator. So a lot of our biomes only occur in the north versus the south. Okay, so tropical rainforest is the first one. Okay, there's lots of tropical rainforest, obviously, in South America. That's where the Amazon is, the biggest tropical rainforest in the world. Okay, so much of that is there. You'll also see some kind of in the Horn of Africa here, a little bit over on the other side of Africa. Okay, here, Madagascar's got some. Okay, basically all of Southeast Asia. Okay, so Laos, Vietnam, okay, places like that. And then you've got, kind of like Papua New Guinea and Indonesia and all those kind of places over here, okay, that are all tropical rainforest, kind of jungle-like islands, okay, Philippines and kind of that kind of thing, right? Everyone with me there? Okay, so what kind of characteristics do you suppose tropical rainforest is going to have if it's always near the equator and it's a rainforest? Hot and humid, and how much rainfall? Lots. They don't call it a rainforest for nothing. Okay, it's flooded most of the time. All right, next one would be savanna. And savanna occurs in basically the same latitudes as the tropical rainforest. It's very much an equatorial climate. It's also very wet. It gets about as much rainfall as the tropical rainforest does. The issue with it is it doesn't get it evenly. Okay, it doesn't get it evenly throughout the year. The tropical rainforest gets tons of rain, but it's even throughout the year. Okay, the savanna gets a monsoon season and then like 7 months of drought. Okay, but in that monsoon season, they get meters and meters of rain. It just pours and pours for months. Okay, and then it stops raining, the sun comes out, and it bakes everything dry for the next 7 months. All right, so it's very much a very different looking place. Right, it's basically like a tropical grassland, if you can imagine what that might look like. Right, and so we see lots of savanna in Africa. Okay, so if you're going on safari, that's probably where you would go. That's where, you know, the lions and tigers, but not bears, will be. Okay, and then there's a little bit here in South America. A lot of savanna ends up being produced artificially. Through what process? No, artificially. It's produced artificially by people. Deforestation. Yeah. Okay. There's a lot of deforestation, a lot of logging that's going on in the tropical rainforest in the Amazon right now, because there's a demand for the exotic kind of soft and hardwoods that are produced in the tropical rainforest. Especially for things like flooring, where you can, because they have really nice grainy appearances, and so people like that for their floors. And like when I first met my wife, she had just built a house and she had put in this amazing looking hardwood floor, and I was like, "What kind of wood is this?" And she's like, "It's Cabruva." And I almost left. It was like our fifth date or so. I was like, "Oh, that's savage. Those are endangered trees." She didn't know. It was okay then. She felt bad after. Too late. They were already harvested and on her floor. But anyway, okay. So yeah, there's a lot of deforestation and harvesting that goes on, and that ends up producing, okay, areas that become more of a grassland. Even though there's lots of rain and it's even rain, it's hard to rejuvenate a tropical rainforest. It takes a long, long time for that to happen. Okay. Then we got desert. Okay, true desert is the kind of the darker gold color here. Okay, so obviously the Sahara. Okay, across the middle of Africa there. Okay, so you know, Egypt and all that. The Middle East is all desert, true desert. Okay, some of this is, you know, the shifting sands of Tunisia and places like that. Okay, if you've seen any of the Star Wars movies, Tatooine and Jakku are both filmed in Tunisia. Okay, which is just rolling sand and dunes and whatever else. So that's very much what they look like. But there's also a lot of rocky kinds of deserts as well. So desert doesn't have to be equatorial. There can be, okay, more mid-latitude deserts. Okay, the Mojave deserts. Okay, so Utah, Arizona, bits of Nevada. Okay, are more of a mid-latitude deserts. Okay, they don't necessarily, they can have seasonality, but what do they all have in common? They don't have to be hot, but they got to be dry. Okay. All right. Now here's an interesting one that you can really see. What mountain range is right here? This is the Himalaya mountains right here. Okay. And what do you notice behind them? A desert. What kind of desert would that be? If it's right behind some mountains. That's the Gobi Desert, and it's the rain shadow desert from behind the Himalayas. The Himalayas cast a very big rain shadow, okay, as they are the tallest mountains in the world. Okay, and you can see this is where the term rain shadow comes from. It almost looks like the Himalayas cast a shadow behind them, right, where there's very little rainfall, right? And obviously on the borders of desert, very often you see this other gold color, which is prairie. Right, so there's lots of prairie here through Asia, okay, and there's a fair amount of prairie here in North America where we are. Okay, this is the grain belt in here. This is where we grow a lot of crops and food. Okay, worldwide, same here. Okay, lots of crops, food, whatever are grown in those areas. Okay, there's a bit of prairie here and there. Okay, in other parts of the world, some of it tropical. Okay, some in Australia here before you get to the outback. Okay, would also be kind of grasslands kind of things. Okay. The whitish blue color here, we really only see it on the tops of mountains, okay? And that's extreme Arctic desert, okay? It's nothing but rocks and ice. There is, however, one landmass that is missing from this map that should be that color. Antarctica, okay? The continent of Antarctica should be down here at the bottom and should be all that color. It's covered in a giant glacier, okay? So that's all it is. Antarctica is actually the driest continent. It gets the least amount of precipitation of any place in the world, even though it's covered in a sheet of ice, okay, that's like a kilometer thick in places. It's just because it's been down at the South Pole for, you know, a very long time, and so it's had time to build up, okay, and it doesn't melt. So, all right, chaparral. We sometimes call this Mediterranean or sclerophyllous forest. Okay, it's a very hot kind of dry type of climate, not desert, because it does get rain and it's quite humid, okay? But typically we call it Mediterranean because, well, that's where you find the bulk of it. Okay? It's around the Mediterranean. So if you've been to Italy or Greece or places like that, that's the Mediterranean climate, that's the Mediterranean biome. The types of trees and things that can grow there would be like olives, grapes do really well in those kind of places, things like that. Okay, but it's quite hot, but there's seasonality for sure. Okay, lots of humidity. There's a little bit here in Southern California and like Baja, places like that would be a little bit that way. Okay, and just a tiny bit of it here at the tip of Australia, and a tiny bit there in South Africa. Okay, we talked about temperate grassland already, the prairies. Okay, that's obviously the biome in which we live. Okay, temperate deciduous forest. Okay, is this kind of grayish green color or bluish green color here? Okay, you can see that most of Europe is that color. It would probably have been changed a little bit because a lot of that forest is gone due to deforestation. Okay? The Industrial Revolution kind of took care of a lot of that, okay? Fueling the furnaces and things like that. Okay, but obviously much of the eastern seaboard of the United States and central Canada, okay, around the Great Lakes, okay, that's temperate deciduous forest because deciduous trees do what with their leaves? They lose them, yeah. A deciduous tree loses its leaves every year. Okay, so this is maple trees and oak trees and things like that. All right, the taiga. Okay, the taiga is a very large biome globally speaking. Okay, but it's very remote. Okay, it's difficult to get through, right? Places like if you've been up to Fort McMurray, okay, or if you go into the mountains a little bit, you're into the taiga, where basically you see like a carpet of spruce trees, okay, laid out before you. That's the taiga, right? It's very difficult and very kind of hard country to be in. It is, however, very resource rich. There's lots of coal typically in the tundra. There's also lots of oil and gas typically in the tundra. Okay, that's why, obviously, up in this area in Canada, that's where our oil sands are. Okay, much of it under the taiga. Russia has got basically the same thing. Okay, Russia's becoming a big power oil-wise because they've got a lot of oil sands as well. Okay, and then above that, okay, you basically get into the kind of true Arctic, the tundra. Okay, and the tundra is basically an Arctic grassland. It is too cold to support any large plant life because the soil remains frozen except for maybe about the first couple of inches of soil depth. Okay, it's just the winters are really long, the summers are really short. Okay, that sort of makes sense on distribution. All right, so now we'll go into some detail about each one here. All right, tropical rainforest. Anyone ever been to a place where they were in the tropical rainforest? Like if you've been to Hawaii, certain parts of Hawaii are tropical rainforest, and other parts of them are rain shadow deserts. Okay, you can tell once you get to the other side of the mountains, everything just kind of disappears. One side of the island is volcanic rock, and the other side of the island is lush forest. Okay, so the big thing about tropical rainforests is that they have layers. Okay, there's sometimes up to 6 or 8 different layers of vegetation within the rainforest. So down near the bottom, there's not a lot there because not a lot of, well, I shouldn't say it, there is actually quite a bit there, but it's not tall trees, obviously. The trees that are near the top only have leaves at their tops, which is why they're called the canopy trees. The undergrowth stuff has to be very shade tolerant because there's layers and layers of forest that are taking up the sun, okay, before it gets down to that level. Right? And obviously near the bottom, they have to also be very flood tolerant. Okay? Basically, they got to be able to survive being submerged for periods of time. All right, so the general characteristics of the tropical rainforest is that they are very hot and very wet. Okay, high temperatures, high rainfall, high humidity. Okay, there's more precipitation than there is evaporation, which means more rain falls than evaporates. And that condition is always going to lead to flooding. And if more rain falls than can evaporate, it stays there and it floods the area. So there's a lot of flooding. You'll often see that people who live in that area build houses that are on stilts. Okay, because they know that for parts of the year the river is going to run under their house. Okay, you don't dig a basement. Okay, you don't have things like that if you live in the tropical rainforest because it'll just be full of water all the time. Right? Okay, if you have lots of rainfall, lots of vegetation, you also have lots of bugs. if you don't like bugs, don't go on a vacation to the tropical rainforest because you will not have a good time. There are lots and lots and lots of bugs, and some of them are very big and scary looking. All right, so if you look here kind of vegetation-wise, okay, this is in Hawaii, and you can see that the mountains have vegetation basically all over them, okay? The steep sides, everything, it grows everywhere, and that's because they get so much rain, okay? Our mountains are very steep as well, but you don't see much growing on the sides of them because the sides get dry. We don't get enough precipitation for something to kind of latch on and actually maintain itself. Whereas here, it's like a chia pet, if you've ever seen one of those. Okay, the stuff just grows all over it. Okay, all over the surface because it's just that wet. Even this rock spire here, that's obviously just almost like a cliff on all sides. It's got vegetation growing all over it. It's that wet that they can grow even in those conditions. Okay, and you can also see that there's many different kinds of plants. Okay, a forest in Canada, you got like 5 different kinds of trees, and they're all pretty much the same. Okay, you got this kind of spruce and that kind of spruce and that kind of spruce, and maybe a pine or 2, and there's your 5 trees. Okay, whereas in here there could be hundreds of different kinds of trees. Okay, and you can also see again the layering here. Okay, there's different kinds of trees at the high points. Okay, climatogram for a tropical rainforest. The temperature line. What do you know about the temperature line? It's the same. Yeah. Okay, it's flat. There's no distinct seasonality, no hot and cold. Okay, and what do you know about the rainfall? It's wet and it's consistently wet, right? This is rainfall in millimeters, 200 millimeters of rain. That's 20 centimeters of rain. Okay, and that's monthly. Okay, that's how much rain we got when it flooded in 2013 in 1 month. Yeah, not good. Okay, they get that all the time. All right, so you get some idea kind of what a climatogram might look like for a tropical rainforest. Okay, soils in the tropical rainforest, believe it or not, are incredibly poor. The only reason that thick, luxuriant vegetation can develop is because they can pull all the nutrients out of the floodwaters that are typically there. Right? If you're trying to do any farming in the tropical rainforest, you are going to be really out of luck. All right? You first off have to clear land, and how do they do that? Do you have your hand up? No. Okay. They do it through something called slash and burn agriculture. It is aptly named. That is exactly what they do. Slash down the trees, set them on fire, okay, and then try and farm where the trees were growing. Well, the problem is that there's basically no nutrients in the soil, because when the soil is always covered with water, the soil becomes saturated, and any minerals that are in the soil dissolve, and then they move by diffusion from a area of high concentration, the soil, to an area of low concentration, the water. Okay? Because the water is constantly moving. So the minerals that dissolve into the water get carried away, and new water that's got no minerals in it comes in to replace it, and so that's constantly what we call leaching the minerals out of the soil, sucking them right out like a leech sucks your blood. Okay? So it's constantly drawing that stuff out of there. And so the soils end up being a lot of clay, because the topsoil, all the organic material always gets washed away in the floods. The clay can kind of cement itself down. So you get this red, hard clay that doesn't really release any nutrients or water, and it's really difficult to grow crops. You might be able to get a crop 1 year, maybe 2, and then you'll get nothing after that. The soil will be completely depleted, and then you slash and burn a new place. Right? So it actually contributes to a lot of deforestation. And it's not because the people are dumb. Okay, it's not because they don't know, and this is how they live. Okay, it's the only way they can put food on the table, right? Is to try and grow crops, and this is all they have, right? So it's they're trying to do their best with that. Okay, decomposition is really, really rapid. So if something dies in the rainforest, it decomposes very quick, because when it's hot and wet all the time, there's all kinds of bugs. Okay, and bugs are important in decomposition, bacteria, fungus, all those kinds of things that grow on dead stuff, right? They're using it for food, okay, and they can decompose it very, very quickly. Up here, where it's cold much of the year and much, much drier, if a tree falls, it can sit on the ground for years, okay? I know, like, sometimes I've backpacked in a place and, you could see where a tree had fallen down. You come back years later, the tree is still there. It's a little soggier maybe, okay, but it's still laying on the ground in that same spot. It'll take sometimes even decades for a tree to completely decompose here. In the rainforest, a couple of months tops. Okay, sometimes within weeks, there's already stuff growing out of the dead stuff. Okay, it's just really, really quick. All right, weathering, we talked about that already. That's the, the water rushing over the soil, pulling the nutrients out of there. Okay, and so they're often low in the things that are highly soluble, calcium, potassium, things like that. They tend to be very acidic because if you cover it in water, you cut off the oxygen supply. Okay, and so acid kind of things kind of build up in there. All right, so the soil profile of a tropical rainforest looks a lot like this. There's very little topsoil, if any. Lots of B horizon, lots of clay, okay, because the silty stuff will tend to kind of collect on the bottom and then cement itself together. And then the parent material will be quite a bit below that. Okay, so the vegetation, they're very diverse. Okay, there's lots of different kinds of plants in the tropical rainforest. Right, this is a typical shot of what the tropical rainforest looks like at ground level. Right, it is really easy to get lost in the tropical rainforest, especially if you don't have a machete. Right, you guys know what a machete is? It looks like a sword, except it's for cutting plants down or killing zombies. Lots of times it's a weapon of choice in The Walking Dead. Okay. Yeah, so it's just a big blade, and you just swing it in front of you, and you have to. So that way, it's not so much so that you can walk forward, although it helps. It's so that you can follow your path of destruction back out. Okay, because if you don't, the jungle just closes in behind you, and it's really easy to lose your way. My dad and I made that mistake. We decided we'd go for a little hike while we were in here. It was only chance that we could actually hear the road at one point and kind of walk towards it until we got back to the road and ended up 5 kilometers from the car on the road. Okay, it's really, really easy to get turned around. And it's the jungle is so thick that you can't even tell where the sun is. So you can't tell north and south or east and west. It just closes in with that canopy over top. Okay, so up to 8 different layers of vegetation from the ground to the tops of the highest trees, and up to 100 different types of trees per hectare. How big is a hectare? Well, a hectometer is 100 meters. So a hectare is 100 meters by 100 meters. Roughly the area enclosed by the running track. Okay, outside here. So roughly 100 meters by 100 meters. In a Canadian forest, if you had 100 trees in that area, you'd be doing good. There's not just 100 trees. There's thousands of trees in the tropical rainforest of hundreds of different kinds of trees. Okay, it's that diverse. It's like no two snowflakes are alike. Walk through the rainforest, and it would almost be like no two trees were alike. Okay, there'd be that many different kinds of plants and trees in the tropical rainforest. Okay. They also have to be adapted to withstand all of the flooding. I think I showed you this picture once before. Okay, these are those special roots that are kind of like a snorkel that allow them to get oxygen and nutrients even when the anchoring roots are submerged. Okay, obviously the plants also have to be evergreen. Not that they're pines. Evergreens up here are pines and spruce, but down there they're evergreen. They never lose their leaves. If you lose your leaves in the rainforest, it's because you're dying. Okay, you need to be carrying out photosynthesis all the time. Okay, fauna have to do with the animal life. Okay, that lives in the rainforest. Okay, there's lots of amphibians because it's very wet. Okay, reptiles, very wet. Lots of fish. Okay, in the waters and the rivers of the tropical rainforest. Some of them very big, some of them very small but very aggressive. Okay, there's lots of different kinds of fish in those kind of rivers, and like we said, lots and lots of different kinds of bugs. Some of them very exotic. I've of course put the most exotic bugs on here. Okay, there's lots of bugs that are much less exotic than this. Mosquitoes and things like that are still present. Obviously, you have to be very mindful of mosquitoes in the rainforest because they could carry what? Malaria. Yeah. Okay, so usually you get a malaria vaccination before you go. Okay, praying mantis would be one. If you've ever seen a praying mantis, they sit there and look like they're praying, and then suddenly one of those wicked arms comes out and spears its food. Okay, and then it bites its head off and eats it. Yeah. Okay, it also sometimes does that to its mate. Actually, that's quite common in the insect world. You don't want to be a male spider because you'll feed your family, literally. Yeah. Okay. Because you'll be fed to them. And then you've got the walking stick. Anyone ever seen a walking stick? Okay, they're very aptly named. They look like a stick, and they're very well camouflaged. I had in university a TA who was an entomologist, and he brought in every week a different bug. I don't know what his house must have looked like. It was full of bugs, but he had this big walking stick, and it was easily from my tip of my middle finger to about halfway down my forearm, and he pulled it out, and it just kind of hung onto him. Okay, and if he would blow on it, it would sway like a leaf or branch would in the wind. Okay, and it would have been in a tree. It would have been perfectly camouflaged. When you put it back in the terrarium, I was like, how did you find where that thing was? Like, you couldn't see it. It just disappeared among the twigs and branches and leaves that were in there. Okay? Perfectly camouflaged. It looks exactly like a real stick. And then you got lots of different kinds of beetles, okay, like scarabs and dung beetles. If you've ever seen the dung beetles, they make those balls of poop and push them around, and then eat things off of them. And yeah, apparently that's part of their courtship. They impress the female by making a big ball of poop. The bigger the ball of poop, the more impressive they are. Courtship is weird in some branches of the world. Okay, like we said, lots of different kinds of frogs and other kinds of amphibians. And you have to be mindful of lots of them. I mean, obviously there's lots of venomous snakes and things like that, but you also have to be mindful that some of the some of the amphibians secrete chemicals onto their skin that keep them from being eaten, especially the brightly colored ones. Okay, it's usually the brightly colored ones that are the ones that would be most dangerous. They do that because if an animal eats one that looks like this and then gets violently ill, they'll never eat another brightly colored frog. Okay, so having that bright coloration actually protects most of them. Right? It's called taste aversion. You may notice that if you ever ate something and then got sick, like very shortly after you ate that, you like the next time you even smell that food, you get that kind of reaction, like you're going to throw up. Okay, it's just a psychological thing, but it's called taste aversion, and it's because if you eat something you don't want to eat it again, maybe it was something that wasn't good for you. Right? Like I'm that way with Arby's. Okay. I can't even go near an Arby's. Because both times I've eaten at Arby's, I got food poisoning, and I just won't go there anymore. Yeah. All right, and then you got the little red panda. They're cute. But there aren't very many mammals that live in the tropical rainforest. And if they are, they're what we call arboreal. That is, they live in the trees. Because you can't be subterranean in the tropical rainforest. Why? You'll drown. Yeah. You don't want to be an animal who digs tunnels, because the tunnels will be water slides very quickly. Okay, so yeah, you can't be subterranean. You have to be arboreal, which means you live in the trees. Okay, like the sloth. Okay, I mean the sloth. If this animal was on the ground, it wouldn't stand a chance. You ever seen the sloth move? There's a reason they're called the sloth. Okay, like they're constantly in slow motion. Right? In the trees, they can just hang out literally. Okay, they have claws that look like a coat hanger, and it just goes over the tree branch, and they just hang there. Okay, doesn't require any energy; they just hang. Okay, and then they pick at the leaves and eat them. Okay, this one you can't see his face. They have a weird-looking face, just like shifty. Their eyes are really close together, and yeah. Okay. All right, is that making sense? Okay, again, the big thing here, guys, is that there's lots of bugs, and many of the species are endemic, which means they only live in one really, really small place. Okay, that's why the rate of extinction of species is so high in the tropical rainforest. If you deforest an area that's several hectares, you may have destroyed a plant or an animal that only existed in that particular spot. Okay, so it's they have to do a lot more, and they're doing now a lot more wildlife studies before they allow logging to make sure there's no endemic species in the area that would be made to be extinct after. All right. Okay, chemical cycling, like we said, things decompose really, really rapidly. You can see kind of in the foreground of this picture here, there's a log laying on the ground, but it's already got stuff growing all over it. Okay, when something dies in the rainforest, it's gone quickly. Right? There's lots of bugs, and bugs can make really short work of like dead wood and things like that. All right. We also said, sorry, in the last slide here, I missed it about food chains. The food chains are really, really long in the tropical rainforest. Okay, you got your producers, the plants, and there's lots of those. Okay, and then you got your primary consumers, your herbivores. There's lots of herbivorous bugs and mammals. Well, not so much mammals, but most of the mammals are herbivorous. And then, but because there's so many bugs, the food chains end up being really long. There's the bug that eats the plants, and the bug that eats the bug that eats the bug that eats the plants, and so on and so on and so on and so on. It's really long. Okay, because there's just so many bugs. All right, the savanna. Okay, savanna biomes cover about 12% of the Earth's land area. Again, most of that being in Africa. And this is what they look like. Okay, they're a tropical grassland. Okay, yes, there's trees here and there. Okay, kind of in places where there might be a spring or something like that that would keep that soil or that area a little bit wetter during the dry parts of the year. And the trees generally all have the same shape. They're flattened on the top. Tall, but flattened on the top. They don't have growth any lower down. Anyone know why they would grow like that? That's part of it. Yeah, the taller you get, the less animals can eat you unless they can climb or they're a giraffe. What else? Like this tree here is shaped like this. Kind of looks like an umbrella. Okay, and that umbrella shape shades their roots. Okay, so in the summertime, or in the, not so much summer, but in the dry seasons, the 7 to 8 months where they don't get any rain, this prevents the soil around the roots from drying out. And so it maintains a little more moisture around their roots by having that shape, right? You look at trees generally have a certain shape for a reason. Pine trees have that triangular shape because it allows snow to land on the leaves, but then also to come off before it gets too heavy and breaks the tree. Okay, so there's always kind of a reason for a plant to have a certain shape. All right, climate-wise, okay, you can see that the temperature line is just like the tropical rainforest. All equatorial biomes have a temperature line that looks like that. It's actually a line. Right? The temperature doesn't change throughout the year. But what you do notice here is a pretty significant change in rainfall. Right? There's a couple of months that are really, really wet, a few months that are pretty wet, and then a bunch of months where there's practically no precipitation at all. All right? So this would be our monsoon season. Okay? 4 months of pouring, driving rain. Okay? And then, you know, kind of a bit of precipitation in the months preceding that, and then basically nothing, right, for the rest of the year. Right? Remember, in the tropical rainforest, we were looking at about 200 millimeters per month, but all year long. Okay? Wettest month here, 350, sometimes even in some places 400 millimeters of rain in a month. Okay? That's almost half a meter of rain in a month. Right? And so they get that for several months. So there's a lot of flooding. Okay? Rivers come up and get really, really high, and there's a lot of runoff. Okay? And then again, it gets really, really dry after that. Okay, so they have a distinct dry season. Lots of plants will estivate, okay, become dormant. So the opposite of what our plants do here. Our plants go dormant when it gets cold. Their plants go dormant when it gets hot. And precipitation is variable. Okay, so even though if you were just looking at the numbers, it would look like the area was really wet. It is, but remember that it comes in a short period of time. Okay, wildfires are a big problem. Obviously, during the dry season with no rain, okay, lightning strikes can cause wildfires. Human activity can cause wildfires, and that actually keeps a lot of the woodland down. Okay, but a lot of the plants are also fire resistant. Okay, the eucalyptus tree, for example, it can be burned right down basically to the trunk, and it'll grow back. It has a bark that insulates the inside of the tree from the heat of the fire. Okay, so it'll sacrifice its leaves, but the tree will survive. Okay, so some plants are able to do that. So we got some cheetahs here. And what's this thing that the cheetah is sitting on? Yes, it's a termite mound. So that whole hill is basically like sawdust. Okay, because termites are ravenous. They will take a tree down in no time at all. Okay, and what they do is they make hills, kind of like what ants do, except the hills are made out of their poop. Yeah. Okay. The termite mound is basically made out of the chewed up pieces of tree, okay, and whatever that they create. And these can be quite tall, right? I mean, you look at that cheetah. Cheetahs, you know, they're a decent sized animal, and it's taller, much taller than this one is. Okay? A cheetah would be at least waist high, if not chest high, okay, when it stood next to you, because they got long legs. right? So this is twice as tall as they are. So lots of bugs again in the savanna. Tropical areas typically harvest lots and lots of bugs, but termites are a really big deal. The problem with termites is that they can go after a living tree as well as a dead tree, but they'll go after any plant material, seeds included. It makes it really hard for plants in the rainforest, in the savanna, to seed themselves because the termites will just eat anything. Okay, so lots of the trees are fire resistant. Okay, with the action of fire and the voracious appetite of termites, seeds rarely survive. So in response, trees produce enormous numbers of seeds every year. Okay, savanna trees are xerophytes. That means they can tolerate drought. Okay, they also have deep roots and flattened crowns, and there's lots of tropical grasses. Okay. In these pictures here, these were taken actually they were in Hawaii, well, this one wasn't. This one's in Africa, this one's in Hawaii. Okay, you can see that the grass looks quite tall, and that's because it is. This stuff here in the picture on the right is elephant grass. It's closely related to bamboo. It can grow really, really tall. That's why it's called elephant grass. Elephants can walk through it and be invisible. Okay, I had a kid here about 4 years ago, and he was from South Africa. He had moved here, and he said, "Oh yeah, that elephant grass, that stuff's for real." Because people don't often believe me when I tell them it can be like 3 to 4 meters tall. He said, "Yeah, it grows around our house, literally. Like it'll grow over the roof if you don't keep cutting it down." So yeah, like when they would leave their house, they would go to their summer house or whatever. They'd come back in the fall, and the house, they said you could see the road leading to the house, and you couldn't see the house because the elephant grass would get that tall. So it's pretty crazy stuff. But obviously, then there's a lot of food, okay, which is why there's so many herds of herbivorous animals that live in the savanna. You got wildebeests and giraffes and elephants and all those kind of things. There's got to be a lot of plants around for all of them to eat. Okay. All right, so there are places, and again, you can kind of see it in this picture here, where the grass can actually grow taller than the trees. Okay, and you can see here that like the trees barely stick out from the grass. And that's not because someone laid down in the grass to take the picture. Okay? It's because someone stood up on a ladder to take the picture. Yeah. Okay, savanna soils, you don't see the same striations or layers that you see in a lot of other places, simply because there's a lot of erosion. When you get a whole bunch of rain at one time, you get a lot of runoff. Okay, so it can erode the soil pretty quickly and then deposit all of that eroded soil somewhere else. So you get patches of soils that are very different. You don't have one kind of uniform soil like you have in the prairies, like up here, okay? But in the savanna, you'll get like a chunk of soil that's got certain characteristics because it washed a bunch of stuff to that spot, whereas you go a kilometer away and the soil is completely different, okay? But typically they're quite sandy because sand and silt and things like that get carried away easily in floodwaters. Okay. There's lots of organic material because it's a grassland, and grasses every year die and grow anew from below. Okay, so you always get this layer of thatch that builds up and creates even more soil. Okay. And it's good to have those grasses there because the grasses can help to prevent erosion. Okay, if the roots of grasses are anchored and thick, then the water can't pull it away. Okay. Opposite of the tropical rainforest. In the tropical rainforest, the food chains are really, really long because the animals that make them up are really, really small. In the savanna, it's the opposite. The herbivores are big, so the food chains are short because you have to have a big predator that can take down a big herbivore. Right? So you typically have much shorter food chains. Basically, the top predator preys directly on the herbivore. Okay, which isn't the case in most places. Most places you have a herbivore and then something that eats it and then something that eats that carnivore at least. But in the savanna, it's lions eat wildebeests and that's the end. Okay, or whatever they can take down. Okay, antelope would be another one. Okay, that would be a herbivore that would live there that cheetahs and things like that would take down. Okay, making sense there? Yeah. Okay, and then for chemical cycling, it's pretty rapid because again, it's warm and it's wet, okay, and there's lots of bugs, okay, and the more bugs there are, the quicker things can get broken down, especially with all those termites, okay. Agriculture isn't a really profitable venture Because if you plant crops, termites go, thank you. Okay, and they devour your crops. Okay, the thing with elephant grass is for some reason termites don't seem to like it. Yeah, that's why it can grow so tall and be kind of a big thing. So it's tough. You have to use like a lot of pesticides and things like that. The other issue is if you are unlucky and you don't get your crop harvested, the floods will destroy it. Okay, the monsoons will come and destroy your crop and you won't be able to harvest it. Or if you plant it too early and you get like another big set of thunderstorms, it'll wash away all of your seed. All right, so it's a difficult venture to do that. Okay. All right, and again here, this is just showing you again that canopy kind of structure that the plants in the savanna have, the trees at least have. Okay, very, very tall. You can see why giraffes need such long necks. All right, deserts. Okay, deserts can be rocky or sandy or both. Okay, the thing that all deserts have in common is that they're all dry. Okay, so whether they're a cold desert, a hot desert, or a mid-latitude desert, okay, they're all dry. The difficult part of a climatogram for a desert is that all the temperature lines could be different. It could be a bell curve, it could be a flat line. Okay, it's hard to tell, but what you would look for would be the precipitation bars would be small to absent. Okay, on a desert climatogram, that would be the thing to look for. Okay, this would be one that would be in like Arizona or Southern California maybe, okay, like Chimney Rock and places like that. Okay, gets really hot in the summertime, but gets cold in the winter. Sometimes they even get snow, okay, in the deserts of Arizona. Like Flagstaff, Arizona has a ski hill, okay, but it's very, very dry there through the summer months. So we got to watch kind of that. We always want to be looking for the really low temperature bars. Okay, so this would be a hot desert. Okay, a hot desert, we see that the temperature line, it fluctuates a little bit. It goes from the lows of about 22 to highs of about 36, 34 to 36. Okay, so very hot, but you can see no precipitation for months. Their wet season, okay, has like 50 millimeters of rain. Yeah, about that much. Okay, so not much at all. This would be an example of a desert, again, kind of in like Arizona. You can see the saguaro cactuses in the background there. Okay, so you'll have cacti that grow, lots of scrub, mesquite, and things like that, things that can really tolerate that kind of weather. Okay, questions there? Okay, so the vegetation, there actually is a fair amount of vegetation in the desert. Okay, I mean, we picture them as these wastelands, but there can be quite a bit of vegetation. In fact, if you go to Arizona in the springtime, it's actually quite pretty. Lots of the cacti are in bloom and things like that, and you'd be surprised just how much grows there. I mean, you look around, yeah, there's lots of spaces where there's not very much, but there's grasses growing. Okay, there's little scrubby kind of bushes and palms, and obviously the saguaro cactus. Okay. Saguaro cactuses can be, cacti, I always say cacti, can be very old, okay? They have to be between 80 and 100 years old before they grow their first arm. All right, so, if you see the one that's like the taco time sign that's got 2 arms on it, okay, that's a pretty old plant. Now, they grow their first one at about 80 to 100, but they grow them about every 5 to 10 years after that. So if you see one that's got lots of arms, it doesn't mean it's thousands of years old, but it's probably pretty old. Okay? They grow for a long, long time. Okay, soils, practically no topsoil. Why wouldn't there be any topsoil? Yeah, well, there's not much plant life, and the A horizon is mostly organic material. So if you only have stuff that maybe like cacti that don't even have any leaves, okay, and you got mesquite that also don't have many leaves. Most desert plants are not very leafy, okay, and that there aren't very many of them. When they die, they dry up almost right away, and they don't stay on the ground to build up. They blow away. Right, so there's not a lot of organic material to build up a layer of topsoil on the top. Okay? It dries up, wind comes up, blows it away. Okay, so it's hard to develop any topsoil. You do typically find a lot of weathered, broken rock all the way down. Okay. Okay, and then if you're going to be an animal in the desert, you got to be able to survive with very little water. Okay, so a lot of them are nocturnal. A lot of the animals won't come out until it's nighttime when it's much cooler. And then you got a lot of reptiles with scaly skin that doesn't allow for a lot of evaporation. You get and then maybe some birds like hawks and things like that that are hot, drought tolerant types of animals. But you're not going to get a lot of big mammals. Okay, because big mammals require a lot of water. Now, obviously, there are some exceptions. Camels being an exception. Okay, camels can survive in the desert. They've got the humps. Okay, now people imagine that these humps are like water tanks. Okay, which is not that's not the case at all. It's like lumpy bulbous scar tissue almost. Okay, and while there is a lot of fluid in there, it's not like they just oh I'm thirsty. Okay, and tap the hump for a little bit of water. Okay, what the humps actually do is they allow a lot of blood flow in there, and they allow the camel to transfer a lot of its body heat into that fluid and radiate it out into the environment, so it doesn't overheat. So the hump is actually hotter than the rest of the camel a lot of the time. All right, we'll talk about the rest of them tomorrow.